Bristol Community College, Mathematics with Dan Avedikian, Math 132, Calculus with Applications, Section 15.2, Problem 10. This is Section 15.2, Problem number 10. We want to find the integral of e to the x dx over e to the x plus 8. Now, the problem with this integral is that we have variables in the denominator that are not easy to get rid of. So we're going to have to do the substitution method. There are two choices that fit. Again, there's four choices in general. Your u could be stuff in parentheses. We have no parentheses in this question. Can't be that. The u is sometimes stuff under the root. There is no root in this problem. Can't be that. The u could be stuff in the denominator. There is a denominator, so the u could be e to the x plus 8. And the last option is power of e. This one does have an e, so it could be that too. So the u could equal x. Well, I'll eliminate that one. You're never going to do a substitution of u equals x, because if you can't solve the problem with an x in it and you do a substitution of u equals x, it's going to be the same problem again. You still won't be able to solve it. So that's going to lock me into what's in the denominator. So the u will be e to the x plus 8. That has to be the choice for you. You'll never do u equals x as a substitution. So now, next we find the derivative, du. So to find the integral of e to the x, you have to remember back a few sections. The derivative of e to some stuff, it's stuff prime e to the stuff. The stuff, or exponent, is just x. So stuff prime, the derivative of just 1x to the first, is just 1. And then e to the stuff, so e to the x stays the same. Now the 8 has a derivative of 0 because it has no x with it. And then you put dx for derivative with respect to x. And the 1 in front of the e, you really don't have to write it. So instead of 1 e to the x dx, I could just say that du is equal to e to the x dx. So now when I rewrite the problem in terms of my new variable, in the numerator, I have e to the x dx, and I have an exact perfect match for what e to the x dx is. The numerator is equivalent to du. And the denominator, e to the x plus 8, I have a perfect match for that too. It's equal to u. So I have to take the integral of du over u, which can also be written as the integral of u to the minus 1 du. So this integral has come up in the past couple of problems. And as you're trying to use the regular formula for the integral that we usually use that works for every negative exponent except negative 1, it doesn't work. If you try to use that, you'll have 1 over the previous exponent plus 1, u to the previous exponent plus 1, and the denominator of negative 1 plus 1 gives me a 0, which I cannot have. I cannot ever have a 0 in the denominator. So that's telling me I am using the wrong formula. The right one would be the natural log. So I'm going to have natural log of absolute value of u plus some constant. And to finish it, you don't want to leave u. You want to write your answer in terms of the original variable. So I have the value of u, which is e to the x plus 8. So my final answer will be the natural log of absolute value of e to the x plus 8 plus a constant. Now in this particular case, e to the x can't ever be negative for any value of x. Even for negative values of x, the result will be positive. The plus 8 will also be positive. So in this one particular case, if you forgot to use the absolute value, it would be okay. There's no harm in leaving it in though.